Good afternoon, students. My name is Dr. MPVV Bhaskar Rao, Mathematics faculty. Today, I want to discuss Mathematics 1 previous year question paper. Okay. So, let us see the first question. So, if f of x is given by sine inverse of x, then you need to use Lagrange's mean value theorem to prove that b minus a by root over 1 minus a square less than sine inverse b minus sine inverse a less than b minus a by root over 1 minus b square. Okay, so we know the statement of Lagrange's theorem. If f of x is the function defined on the interval a comma b, then f of x is continuous on closed interval a comma b. F of x is differentiable on open interval a comma b, and you need to take f dash c equals to f of b minus f of a by b minus a, and you need to prove that c lies between a and b. Since you need to use Lagrange's mean value theorem, so we can have c lies between a and b, and also f dash c equals to f of b minus f of a by b minus a. So you can make use of these two statements in order to prove the inequality b minus a by root over 1 minus a square less than sin inverse b minus sin inverse a less than b minus a by root over 1 minus b square. Now I have evaluated the derivative of sin inverse x. Sin inverse x is the function f of x. The derivative of f of x, that is derivative of sin inverse x, is 1 by root over 1 minus x square. Then I have taken f dash c equals to f of b minus f of a by b minus a. Since f dash x is 1 by root over 1 minus x square, then f dash c will be 1 by root over 1 minus c square. Since f of x equals to sin inverse x, then f of b is sin inverse b, f of a is sin inverse a by b minus a. Also, we have c lies between a and b, that is a less than c less than b. So, squaring on both sides, it will be a square less than c square less than b square. Then I have multiplied minus throughout, then it will be minus a square greater than minus c square greater than minus b square. Then I have added 1 throughout, then it is 1 minus a square greater than 1 minus c square greater than 1 minus b square. Then I have taken square root on all sides, it is root over 1 minus a square greater than root over 1 minus c square greater than root over 1 minus b square. Then I have reversed all the terms, then it is 1 by root over 1 minus a square less than 1 by root over 1 minus c square less than 1 by root over 1 minus b square. And previously we have proved that 1 by root over 1 minus c square is same as 1 by root over 1 minus c square is same as sin inverse b minus sin inverse a by b minus a. So I have replaced the term 1 by root over 1 minus c square with sin inverse b minus sin inverse a by b minus a. Since b minus a is the positive quantity, so multiply throughout by b minus a. Then you get the inequality b minus a by root over 1 minus a square less than sin inverse b less than minus sin inverse a less than b minus a by root over 1 minus b square. Now let us see. Next question in the previous question paper. If u is equals to function of e power y minus z, e power z minus x, e power x minus y, then you need to prove that dou u by dou x plus dou u by dou y plus dou u by dou z equals to 0. So for our convenience, let us suppose e power y minus z as p and e power z minus x as q and e power x minus y as r. So in this step you can replace e power y minus z by p and comma q comma r. Then it will be u is a function of pqr, where p is a function of yz. So you can consider p is a function of xyz, q is a function of xyz, and r is a function of xyz. Now let us consider the first term dou u by dou x. So by using chain rule, so dou u by dou x will be, since u is a function of three variables p, q, r, then dou u by dou x will be, you need to take the derivative of u with respect to first variable, that is p, and derivative of first variable with respect to outside variable, that is x, plus derivative of u with respect to second variable, that is q, and derivative of q with respect to outside variable, that is x, and derivative of u with respect to third variable r, and derivative of r with respect to outside variable x. So this is the formula for dou u by dou x with the help of chain rule. Okay. Since dou u by dou x can be written as ux, and dou u by dou p can be written as up. Now, P is clear here. Then dou P by dou X. Dou P by dou X, since P is not containing X term, P is not containing X term, then dou P by dou X is 0. And dou Q by dou X is derivative of e power z minus x is e power z minus x, and the internal derivative for z it is 0, for x it is minus 1, so it is minus of e power z minus x. And dou R by dou X, derivative of e power x minus y with respect to x, it will be e power x minus y, and derivative of x is 1 and derivative of y is 0. So you got ux as up into 0, uq into minus e power z minus x, and ur into e power x minus y. Since u is a function of pqr, by replacing p by q, q by r, and r by p, you will get function of q r p. Okay. So this is a symmetric function. So similarly, you can write uy and uz, and adding all those terms you will get 0. Thank you.